Your units are here, kilonewton per meter. And you do the same for live load or variable load. So assign frame load, gravity. I'm not sure if it says gravity. Let's see. This I think because it says gravity already, it will automatically take it as downward. But double check it, I'm not sure now. So for live load, you select live load here, and live load for these secondary beams are 10. 10 is this combination is not correct for this model because our permanent load is 4. So our dead load is 5 times 1.67. And our live load is 1.5, so 2 times 1.67. So this rate calculation is for your part 1, but when you want to do your model, you need to do it separately, and the combinations will be automatically there. So you don't need to do combinations in your model. Okay? So your dead load here is 8.5, and this is 3.4, for example. So here he corrected it. So for live load was 3.4.
We're using 3x3A before, not 3x2.
And dead load is 8.5. Here you see that it says replace existing load. So that mistake will be corrected automatically. So these are our dead load, 8.5, to these secondary beams. You do similar calculations for all other beams, including external walls here. Okay? So you apply, for example, for this beam, you have got for this beam you have got dead load got 5 times 16.7 over 2, and the live load is 2 times 1 over 2. For dead load you also have got external wall, so it
15
plus 15. Yes. So for this one, because you have modeled these secondary beams, it will automatically apply loads here. So the only thing you need to consider for this one is just external. Well, are you with me?
Yeah.
So far, so good.
Oh, I'm very pleased. Your friend
It's because it's very different.
So for this beam, just external wall, okay? Because you have designed, you have modeled the secondary beams. For this one,
This is too late.
for the staircase,
Only because
you have got external wall plus this tributary area and the load from staircase. Just consider load for the staircase to these beams. if you remember these inclined beams, these will apply loads on these shorter beams, yes? So just calculate the load for the staircase and apply as uniform load to these two beams, plus the external loads. Yes? And for the lift, just consider the external loads.
Yeah, because the hand.
Because the structure of the lift is something separate. Okay? So for the lift, just consider external loads. And for the staircase, just consider the external load plus the load of the staircase to these beams as uniform load. Okay? These are the questions you had last year.
Yeah.
So, if you remember last year, we assumed staircase as 4-point loads, but this semester we want to be more accurate. Okay? So, after applying all these loads to this beam, if you assume a similar loading for typical floors, we just need to copy and replicate these beams. So again, go to X, Y here, then you select all these, edit, replicate. These there is 3.2, the distance between the stories.
3.2, no.
You put 3.3.
3.2, and the numbers are 5. Yes? The roof load, you assume roof load similar to the floor load. Okay? But if you want to do more accurate, we can still do this.
Number 6 or 5?
Number 5.
4, it's not 5.
Oh, sorry, 4, yes. So you undo,
It's cut.
edit, replicate, 4. So if you want to modify the load on the roof, it's okay. For your, if you want in your professional work, for sure the roof load is different than the floor load. So you can right click on these elements on the roof and modify it. But for this, you don't need to do that. And now we define the columns. So we go here, we go to XZ view, for example. XZ view, we are here. See these blue lines. So again, we click this line element. Now we choose a column, UKC. And our columns are continuous between stories, yes? Except, yes, it's continuous between stories, and we define the support reaction later. So we just click simply here between stories, and then right click, and then we start here. In reality, these columns in bottom stories have got stronger sections. So you choose stronger sections for the bottom columns and lighter sections for the top columns. You go to another elevation, do the same.
Do you choose the same section for the first floor column?
Yeah, I'm choosing the same sections for all the columns, but it's not correct. You need to change the sections instead.
Every time you go up, or
Yeah, it depends. Choose
Like the first two
the
will be-
first 2 stories, one section, then the other 2 stories, lighter section, and finally this one. And you know that in column splice, when we want to change our section, the column splice cannot be at the floor level. It's normally 1 meter above the floor. So if you want to be more accurate, then you have got one column here up to this point. Then you have got another column here up to this point. So our column splice is 1 meter above the floor normally. So you cannot simply, if you just simply change the column at this point, it will not be accurate. If you want to be more accurate, you need to remember that the column splice is there. So you do this for columns. If you want to change the section, you just simply go to this table and change, choose a new section, and then continue your clicking. It's very easy, it's nothing very important. And then right click to...
How do you change the views?
You change the views, you have got X, Y, X, Z, Y. And you communicate between frames by these arrows, okay? Now,
Where are we going to go for
the next step is to define the support reactions here. You again click these. If you drag these, you select these nodes at the bottom for column base. Okay. So you go to assign again, joint, and restraints. In restraints, you choose to restrain these nodes at 1, 2, 3 directions. If you choose rotation, these will be fixed. So for our structure, which is brace, our column bases are just restrained as simply supported. Okay, so it is just restrained in 3 directions.
What do you mean restrained?
It's avoiding movement. So if you assume a simply supported connection,